Hello, everyone. I hope you guys are having an awesome Friday so far. We're so close to the weekend. Woo-hoo. All right. What we're going to be doing today is we're going to analyze uh, a little bit of different uh, atomists, okay, about the history of an atom. I kind of covered little bit, a few of the scientists in previous videos, but I'm going to go over a detail on each one, and that will help you with the upcoming project and with maybe your future test, okay? So let us begin, all right? First guy I want to talk about is Dalton. Dalton's atomic theory. He came up with 5 different things, all right? All matter is composed of extremely small particles called atoms. Atoms of a given element have identical size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. 3. Atoms cannot be subdivided, created, or destroyed. 4. Atoms of different elements combine in a simple whole number ratio to form chemical compounds. And 5. In chemical reactions, atoms are combined, separated, or rearranged. Now, the only problem with Dalton's atomic theory was he messed up in 2 different spots. All right, 2 of these 5 are not correct. Can you figure out which 2 of the 5? Okay, well, one of them is number 2. Atoms of a given element have identical size and mass. Well, that's not true because atoms can have different masses if they have different amount of neutrons. The other false one is number 3. He said atoms cannot be subdivided. Yes, they can. They can be divided into protons, neutrons, electrons. Okay, so that's Dalton. Next, we're going to talk about the discovery of electron. All right, and my man J.J. Thomson used a cathode ray tube and discovered the electron. So what he did was he shot particles from the cathode to the anode and put in an electrical charge. Let me see if I can bring it down. An electrical charge at the bottom here, the plus minus, and he was able to see the bending of when you put up a positive charge, he was able to bend the electrons because the electrons were attracted to the positive. Negative attracts positive, right? Opposites attract, uh, likes repel, right? So that's J.J. Thomson. Then from that idea, he created a plum pudding model, all right, where he put in the positives and the negatives all kind of mushed together in an atom. Now, as we know, that is not what an atom actually looks like, all right? We got some further data to tell us otherwise, but that's what J.J. Thomson thought, okay? Now, when we discovered the nucleus, I think I discussed Ernest before, Ernest Rutherford. What he did was called the gold foil experiment. He shot a ray at a gold foil, and what he observed was some of them went straight through. Some of them bounced off at a small angle, where some of them detected at a large angle. They went backwards. And he's like, how is that possible? Because what he's doing is he's shooting a cannonball at a piece of tissue paper and having it bounce off. What? Is that possible? Well, yes. Because if you look at these lasers at the bottom, he missed, so it can't be like that. So in an atom, you have a dense nucleus. And whenever the light hit the nucleus, it bounced off. Okay. Now, this guy, Robert Millikan, had an oil drop experiment. He was the one to discover the charge and the mass of an electron. All right, the mass of an electron is so very small. 10 to the negative 31st power is so very little. All right, it looks like that. That's a lot of zeros. All right. So what I want you to do is figure out how many, well, I'll discuss the oil drop. So in the oil drop experiment, what he did was he dropped oil into a vacuum, a little pump, and he ionized the pump so that particles had a positive and negative charge to them. And the positive charge was attracted to the oil and connected to the oil. Well, this allowed him to see that electrons were negative because he would put different charges on the cathode on top and bottom. All right, so if it was on top, if he had the cathode on top and he increased the charge, the oil dropped very slowly because it was attracted to that positive charge up there. Where if he put the negative charge, they repelled really fast. They went down so fast they can't even see it. All right. And that's how he got the charge. The mass he was able to see through a microscope. He was able to see the size and record its mass. So I want you to determine how many atoms are in a single breath. Take a deep breath. Breathe in. Breathe out. All right. You just breathed 10 times 10 to the 22nd power. That is so many atoms. Atoms are so small that you just breathe 10 to the 22nd. That is crazy. Okay? So what you guys are going to be doing today, all right? You guys are going to be doing a little experiment or a little research project. Okay? Here is your research project. Hopefully you guys can see this pretty well. All right. Now, Scientist Project. This is posted on Google Classroom. You should be able to find this as the Scientist Project. You have different options. You have different options. Option 1 is you can create a timeline for the 6 scientists below, these 6 scientists, and answer the following questions right here. Number 2, you can choose one of the following scientists and write a one-page paper about them. Number 3, you can create a set of baseball cards. On the computer, you can create a set of baseball cards and answer the following questions for the following 6 scientists. Now, if you want to create a presentation on Google Sheet or Google Slides, that's fine. If you want to do anything, I've had students create a song before. I've had students code. Whatever, I have a student right now writing a poem. Whatever you're interested in and comfortable with doing, I want you to try that out. Okay. This is today's activity and also Monday's activity. Okay. So it's not going to be due till the end of Monday, probably Tuesday morning. Okay. But if you have any questions on this, let me know, please. This is a pretty big assignment, and we should be good to go. If not, I hope you guys have an awesome weekend. Enjoy your weekend. All right. We will see you on Monday.